Okay, we're going to have a conversation this time about phospholipids in the cell membrane. So, we're going to do a little bit of a compare and contrast on a couple of molecules that we've looked at. And really, where we're going is we're going to have a conversation about a molecule that can have a hydrophobic end, an end that doesn't like water. And that's usually the case with a lot of carbons and hydrogens together. And a hydrophilic end, an end that can really likes water, wants to be in water, and that's typical when there's a lot more oxygens than carbons and hydrogens. So let's look first at our triglyceride. So our triglyceride was made up of that 3-carbon alcohol or glycerol. We'll throw the oxygens in there. So this was our glycerol. And we had 3 fatty acids on there. So our big long chains of lots of carbon and hydrogens. So this molecule doesn't like water. There's not much oxygen in comparison to the amount of carbon and hydrogen. Because remember, the fatty acids are chains of carbons and hydrogens. Might be saturated, might be unsaturated, but 16, 18, whatever carbons long. And again, we have our ester bond in there. And just reminding you of that, not super important for this conversation. But now let's look at a phospholipid. And we'll do it in kind of a compare and contrast kind of way. So we still have the glycerol, our 3-carbon alcohol. We'll put the oxygens on it. And on 2 of the carbons, we still have fatty acids, still have big long carbon chains. But to be a phospholipid, we need a phosphate. And we'll have some kind of nitrogen group. So what happens with this molecule is we have a molecule that part of it likes water, part of it doesn't like water. So the fatty acid part here, this doesn't like water. We'll say hates water. Strong word, but shorter word to write. Then we have the phosphate that loves water. So what'll happen is that'll make this molecule arrange in a certain way. So what'll happen is we'll end up, let's put a new slide in. We'll end up with the molecule lined up so that we have the phosphate head, and then we have these 2 fatty acid tails kind of hanging down. So what happens is it's lining up because part of it likes water and part of it doesn't. So here's our loves water part. And here's our hates water part. So what happens in the cell membrane is this kind of all lines up. So remember, cells are in an aqueous environment. So what we're going to do is we're going to take a whole bunch of these phosphates Sorry, I should have drawn this beforehand. They're all going to kind of line up in a circle, and they're going to have their little fatty acid tails all kind of sticking in. So we'll have one round of them line up like that. because we have the water, of course, out here. So those little tails are just trying to get as far away from the water as they can. Then we're going to have another layer. We're going to have another layer. I'm really going to kill this drawing. Line up in the middle with all the little tails kind of lining up, interacting with the other little tails. Because again, we've got water in the middle. So these phosphates are trying to get in that water. They love the water, and their little fatty acid tails are trying to get outside the water. So I know it's a hideous drawing, but that's how we get the phospholipid bilayer in the cell membrane. All the phosphate heads trying to get to the outside aqueous layer or aqueous environment, the other layer trying to get to the inside aqueous environment. And all the little hydrocarbon tails, fatty acid tails, just trying to duck and dive to stay away from the water. So they end up on the inside of this layer, kind of making a double layer of them. So anyway, that's the phospholipid bilayer, or phospholipids in the cell membrane. We're going to talk more about the cell membrane, but I just wanted to give you that structure and how that lines up.